Today's video, I'm going to be solving this system using only substitution. So we're given this problem, and right off the bat, the directions say solve a substitution. And when you're solving a system, like typically you want to go with the best method. But if you're watching this video and you're watching it for the sake of, because it says substitution, I'm going to solve it using substitution because sometimes we only can use a certain type of method. But we do want to be able to just look at a system and understand what the best method to use is. And in this case, substitution isn't crazy, so I'm going to go ahead and use it. So here's how I like to use substitution. First off, I like to write the equations like this. I like to write them side by side when I'm solving using substitution. So I'm just going to write these down. And there's a reason, which I'll show you at the end. So I'm going to use substitution. So what we want when we're using substitution is we want one of the variables to be by itself, meaning x equals something or y equals something. So we want that coefficient to only be 1. So when I'm looking at my options of do I want to get this x by itself, do I want to get this y by itself, this x, this y, I want to try to find, if there is, a variable with just a coefficient of a positive 1. So I'm looking here, that's a negative 1, not going to help us. 3y, that's a 3, that's a 3x, and then this is a 1y. So that's going to be my focus. That's the variable that I want to get by itself because I don't have any just x equals or y equals right off the bat. So I have to solve for y in this equation. And in order to do that, we want to get y by itself. So I'm going to subtract 3x from both sides. And that's going to give me y equals, it doesn't matter if you write it as 3 minus 3x, negative 3x plus 3. I'm just going to write it as 3 minus 3x because we're just doing substitution. We're not like graphing or anything like that. So I'm just going to leave it like that. Now I have y equals 3 minus 3x. That's going to be my substitution. So I am now going to substitute 3 minus 3x in for y into this equation. So I'm replacing y in this first equation with 3 minus 3x because that's what y is equal to. So I'm taking y out of the equation. The common mistake I see here, let me actually write this down and then I'll show you the mistake that I see a lot. So this is going to be negative x, not changing the x at all, plus 3 times the y value, 3 minus 3x equals negative 1. I'm going to write something down and I'm going to erase it, but here's the mistake that I see a lot. I'm replacing y, and I see students do this. Negative x plus 3y, and then they do something like this. Then they write down the 3 minus 3x. What they're not doing, what they're not grasping, the concept that they're not grasping, is that we are substituting out the y. So the y is coming out of the equation and being replaced by something else. Just like in a game of basketball. Point guard is on the court. Point guard leaves, a new point guard then comes into the game. So the point guard is being replaced by another player when there is a substitution. There's not 2 point guards on this. There could be, but 5 players. But let's just pretend like the point guard, there can only be 1 point guard on the court. So 1 point guard comes off, the other one comes on. Same thing here. The y is coming off the court. 3 minus 3x is coming onto the court. All right, now we're just going to go through and solve this. This is just now a solving equations exercise. So I'm going to distribute 3. Negative x plus 3 times 3 is 9, minus 3 times negative 3x is going to be negative 9x equals negative 1. I need to combine like terms on the left side of the equal sign. Solving equations. So negative 1 minus 9 is negative 10x plus 9 equals negative 1. I want to get all the variables on one side, everything else to the other. I already have x on the left side, so I'm going to go ahead and subtract 9 then, because it's plus 9. So I'm going to get rid of that to plus 9 by subtracting. Negative 10x equals negative 1 minus 9 is negative 10. One note I do want to make, I know this is a substitution solving equations video, not a solving equations video, but I do, or solving systems video, this is not a solving equations video. I do want to mention, though, when I'm bringing this down, notice how I wrote this as negative 10x. Not 10x, because this was negative 10x, so I got to make sure I write that down. So now I'm going to divide by negative 10, giving me an x value of positive 1. Here's why I like to do this right-left rather than vertical with substitution. See how I went from here to here? I worked through all of this. Now I'm in a point like, well, now what? I have this x value. Okay, I still need to figure out what y is. Look at this. Boom. Right back there. This equation right here tells me y is equal to 3 minus 3x. Substitute right back in. I have x. Let's now get y. So I'm going to say y is equal to 3 minus 3 times 1. Y is equal to, and then just simplifying this expression, 3 minus 3 times 1. So that's minus 3. Y equals 0. So my ordered pair is going to be my x value of 1, my y value of 0. And a way you could check your work is take this x and y and plug it back into these equations. Replace x with 1, replace y with 0, and see if it works out. But that is solving this system with substitution, and I know after you get some experience, you might look at this system, and if there was no prompt of substitution, you might want to try... This is actually a really good substitution problem. Like, I would probably actually go with substitution because of this 1y, but it's not a terrible elimination because you could just multiply the first equation by 3, and that would create opposites, and then you could just eliminate the x's that way. But there's really no right or wrong way, but the prompt was substitution, so that's how you'd solve this using substitution.